welcome to Functions with Lists. So we're going to be focusing primarily on creating functions that work with lists in this exercise. And then after that I believe we'll take a quiz and then we'll move on to loops. So we've done a couple things. We've changed our IDE to be light colored, and we've zoomed in on this screen a little bit. Now the Codecademy, as far as I know, we can't change the color of the IDE on there. So if you're having problems seeing that, we did increase the zoom size of the recording. So we're hoping that that'll help. And also, all these lessons have been moved onto the GitHub. So a lot of the GitHub code and I believe the 3 apps that we've already built are on the GitHub for you to view as well. And I know that has sort of a lighter color to it. If you ever want to join us for one of these sessions, like live, just email me, let me know. You could be part of the recording. You can work with us. Kevin will be coming in a couple hours. This is going to be, in total, it's going to be around 5 to 6 hours. This video will only be about an hour long, though. What we'll do is we'll end it after functions and lists, and then every time we start a new activity, we'll cut the video there. So if we take a quick look at the GitHub repository, so if you remember last time we've done all these exercises here. So let's look at Sal's shipping application. And like I said, if you're having a hard time seeing it, you can go to the GitHub and all the functions we created and all the unit tests we created were on there. You can always take a look at that. Okay, so let's get started. So these are going to be lessons with functions and lists. So essentially what we're going to do is we're going to be working with lists, but we're going to be working lists through functions. So let's go ahead and read the first requirement, which is we're going to create a function named double index. By now you should be well aware of how to create functions in Python. So it should double the value of an index and an LST. So let's take a look here. And a list. So it's going to take an index and a list, and it's going to return the new list with a doubled value. If the index is not a valid index, the function should return the original list. If the index is not a valid index, after writing your function, uncomment the call. The function is where provided. So okay, so the requirements are we need to enter a list and an index, I guess in this order. So let's change our parameter set to list and index are our 2 parameters. You can see by our unit test down here. So the first thing we have to do is we have to make sure the index is in the list. So we know that the we'll say it, so if the list.length is greater than the index. So the list length, and again, this is old school Python. Let's go ahead and write it correctly, right? Remember, we wrap length around list. So if it's greater than the number of the index that gets inputted, and you know what, I just want to verify that this index is going to come in. This should always be an integer, and I think the length will always be an integer as well. But I'm going to enforce that the length is going to be an integer. I'm going to run this really quick just to see what error we get. Unexpected EOF port. That just means that it's missing closure. So here we have to give something for it to do during the if statement. Well, what we should do is if the length of the list is greater than the index, right? So the index down here is 2. If the index was, the length is 1, 2, well, the length is 0. Well, no, it's 1, 2, 3, 4. And if 4 is greater than 2, then if 4 is greater than 2, then run this. 0, 1, 2, 3. So the length I think should be 4, and index 4 would be 0, 1, 2, 3. Yeah. So if it's greater than, so in this case, if it's greater than 4, run it, and the index here is 2. So the length 4 is greater than the index 2. Then we should go ahead and double the value of the index. Return a new list with the doubled value. So what we need to do is we need to get where the list is currently, okay, and which is where the index within the list will be. And we do that with brackets. We don't do that with parentheses. So, okay, so now we get the list index. And now, whatever that number comes out of here, and you know what? I'm going to rename this. I'm just going to rename this value. Okay, and then what I'm going to do is I'm going to say value is going to be, I'm going to say return. So value is going to be equal to value times 2. And then I'm going to return it into the index. List index is going to be equal to value, and then I want to return the list. Let's run this and see what we got. No parsing errors. And if I enter index 2, I should get 3, 16, negative 10, and 12 back. Let's see what we get back. 3, 8, negative 20. So the index 2 is 0, 1, 2. So the index down here is negative 10. If you double negative 10, it's 20. So this does return back our requirements, but let's write another unit test here. And instead what we're going to do is we're going to use the negative integers for the test. And we're going to run it on index 2 again, so we should get the same list but 20 instead of negative 20, which we do. And then let's change the index. Let's put the index to 5, and the index is outside. So what I'm going to do is I'm going to return an else statement that says print index outside the range of the list. And what we could do is we could do this, right? We could put a quote here plus let's string our index, so str, and put our index in here, and then put a plus symbol, put a quote, space, and then let's rerun this, and then it gives us our nice little message that index 5 is outside the range of the list. Okay. And it returns none. So what we'll do is we'll copy this, and we will go to our IDE, and let's CLS. We're going to create a new file, new file, and we're going to save as, and in basic functions. Check what I have in basic functions. Basic functions. I think I put it all in sessions. So in basic functions, let's create a new file, and let's call it double index value dot py, and then let's paste what we had in there. Let's save it, pressing Control S, and then minimize this and move on to the next lesson here. Remove middle. Create a function named remove middle, which has 3 parameters: list, start, and end. You see, I've already created this. We'll reset that. So we'll do this sort of from scratch. Create a function name remove middle. 3 parameters. List, start, and end. Function should return a list where elements in list are between start and end inclusive have been removed. For example, the following code should return 42342 because it removes elements at indices 1 and 2, being 8 and 15. And then it also removes 16 and 32. Okay, so I forgot how to do this one, so this will be fun. So let's first remove middle, and we have 3 parameters, which are list, start, and end. Okay. The function should return a list where all the elements in the list with an index between start and end are inclusive. So let's look at our unit test. So our unit test 1 and 3 should remove 15 through 16. Actually, it should remove 8 through 16. So in this case, we need to find the length. And we'll say our LST is going to be, that's wrong. Let's do our length of list. I know that's a bit verbose, but what I want to do is I want to get the length of the list first, okay? And then I want to find the middle of list, and I can do that dividing the length of the list by 2. And what we'll do here is we'll just get rid of this, a little bit of refactor. And so the middle of the list should be anywhere within the list. So here we have 1, 2, what just happened? I just got disconnected. No. I didn't click anything, did I? Okay, let's redo this. What just happened? Alright, so remove middle, LST, start, end, middle of list is equal to the length of the list, right? Divided by 2. And let's test this out by printing our variable middle of list. Okay, so let's get our unit test out of the way. Let's run this, and invalid syntax because I didn't put spaces. I did not define this as a function. Okay, so the middle of the list, it says, is 3. So what we should do here is we should convert this into an integer. So we just get a flat 3. Because remember, floats can't be used to find indexes without being converted into an integer first. So by default, if you divide in Python, it will convert it into a float and then do the division and give you back a float. So therefore, you must convert it back into an integer. So what we can do here is we can print middle list, which is a number. But remember, middle list can also actually represent an index. So if we put brackets around it and we enter LST, we should get back the third index here, which is 0, 1, 2, 3. So we should get back 16. So we do get back 16, which is the third. Remember, 0, 1, 2, 3. Okay, so now we know that we're in the middle of the list. So the middle of the function tree in a list where all elements in the list with the index between start and end have been removed. Interesting. See, what I don't get is that for example, the code should return 4, 23, and 42 because elements at indices 1, 2, and 3 have been removed. 1, 2, and 3, but 4 and 5 do not follow this requirement. The function should return a list where all elements in the list with an index between start, we're starting at index 1, this is index 1, okay, and end inclusive have been removed. So, oh, we're ending at 3, so this is 0, 1, 2, 3. So these 3 are supposed to get removed. Okay, so that's not so bad. So that's not so bad at all. So what we can do is we know we found the middle of the list at 16. What we can do is we can remove everything from 1 up to the middle of the list, including the middle of the list. So what we can do is we can print start, right? We can create a splice where we start ... to the middle of the list. Is that how we do slices? No. Is it colon? I think it's colon. So let's run this. We get 8 and 15. Cool. So we have, okay. So we have a splice. We have a splice that starts at start and goes to the middle of the list. What we want to do is this. We get the first grouping. So we want to get everything that starts at index 1, which is start, and ends with middle of the list. So here, let's do the same thing that we're doing now, but we'll start with middle of the list. Okay? And we'll end with end. And let's see what that gives us. That gives us nothing. So middle of list. Did I do this wrong? No? And end with end. Middle of list to end. Let's print this out. Run. So the middle of the list is just 16. The middle of the list to end is, there's nothing in there. Why don't we just put a colon at the end of this, and what does this give us? Okay, so the colon gives us everything from 16 and above, but we just want to get rid of the middle, which I think we said was, it came out to 3. The index was 3, which the index is really 3 and 15. So the middle indexes are actually middle of the list and middle of the list minus 1. Let's see, 1, 2, 3, 4, 5, 6. Yeah. So if okay, so fun fact: if you have an even number of numbers, then the middle numbers are n divided by 2 and n divided by 2 minus 1. And the Codecademy, you guys gotta stop auto putting in parens, or at least make an option that I can turn it off, which I don't think is available. So the middle numbers will be these two numbers. So what we need to do is we need to create a list that will exclude 8, 15, and 16. So we need to slice off the list. So we need to create a new list. Okay? And that new list should be the list of everything up to start. Okay? And then let's unit test it. Let's print new list. Four. Cool. Okay. And then new list 2 should be everything from the middle out to the very end of the range. So the colon here says take everything before start up till start, and take everything after the middle of the list. Okay? And so our unit test here, let's print new list 2, and let's run this. What did I do wrong? New list 2 is not defined. New because it's new LST. Let's run this. Okay. So what? And here's where the problem is. The problem is we need to remove middle of the list as an index. So what we can do is we can say middle of the list, dare I say +1. Let's see if that works. It does. So we're going to cheat a little bit here. We're going to say take the middle of the list, add 1. So middle of the list represents a number right now. And that number is an index. So if you look here, middle of the list is the number 3. We're going to add 1 to it, and we're going to start there, and we're going to move forward from there. So ideally, what we want to do is we want to add these two lists together into one list, where we say new list is going to be equal to new list plus. No, we can't do that, can we? If I remember correctly, we had an incident where we tried to add one thing into a range and it wouldn't let us. I think this can only add one thing. So let's try this. Let's print new LST. Let's see what happens when we print that. So the new list prints out 42342, which is correct. So let's return new LST. Let's run this. Remove everything between start and end, including end, which we did. We did. And it passes the unit test. We're going to remove these unit tests out of the function, and putting your test inside of your function is part of test-driven development. It's a good way to physically see what your code is doing. Okay, so let's go over this code one more time. So we have a list, we have a start index and an end index. We have a variable called middle of the list, which is enforcing integer on whatever the length of the list is divided by 2, converts it into an integer. So you can put any list in here, okay, and it will divide it by 2, and it will force it to an integer. That will automatically get you your middle index. So the new list is equal to the list from the first index, which is 0, to start. In this case, in this unit test, the first index is 1, which is 0, 1, which is the 8. So it says the new list is going to be equal to a list with just everything from 0 to 1, which happens to be 0. New list 2 is going to be equal to the middle of the list plus 1. So we're going to start at the middle of the list. We're going to go one index further. Remember, middle of the list right now is 3. We're going to go one index further to 4. We're going to start there. And then we're going to go to the end of the range. So if we count 0, 1, 2, 3 is 16. Plus 1 is 4. So this is the 4th index. So grab all of this to the end of the range, which is 23 and 42. Then redefine our new list as the new list, which just has the 4 in it, plus the other list we created, and return the new list. Okay, so what we want to do is we want to unit tests. I know we passed, like these passed our requirements, but we want to rerun this with odd numbers. And the reason why is because we want to make sure our math is correct. So what we're going to do is we're going to get rid of the 42, and we're going to run this with 5 indexes instead of 6 indexes. Okay, so this is our first unit test, this guy here. And we want to see what our second unit test is going to look like. And I did not put spaces. I don't know if that'll be an issue, but just to make sure it's not an issue, you can see that we removed the number 42, which makes this odd. 0, 1, 2, 3, 4. 4 indexes are actually 5 numbers, right? 1, 2, 3, 4, 5 total numbers. Let's run it. And as you can see, it works. But this time, the middle is 15. It's not 16 and 15, it's just 15. So let's change this up. Let's just remove 2 and 3. So if we remove index 2 and 3, it should just get rid of these two numbers. And it should give us 4, 8, and 23. Let's see what it does. This gives us 4, 8, 16, and 23. To get rid of 23, we would have to increase the index by 1, I think. No, it doesn't. So this is some behavioral problems that we're seeing. So this is saying that we want to start on 2, 15. Okay, so we should get 4 and 8, which we do. And then on the third index, we should grab 16 and 23. So we should get 16, we do. But look what happened when we increased it to the fourth index. It only has 5 indexes. So it included 16, and if we go to the 5th index, which is really odd, right? Because we're saying index between start and end have been removed. Well, the start of the index is 2. Which is here. The end of the index is 5. 3, 4. Let's see. 2, 3, 4. Actually, it should throw an error. Because this is only 4. 4, let's see. 0, 1, 2, 3, 4. This is out of range of the index. So it shouldn't even print out that stuff. Let's go back to the end of the index though. Rerun this. It should technically get rid of 16 and 23, but it's not. Right? It's not. And let's see why it's not. If we put 2 in here, 1, 2. Okay, so we put in an index of 2. We do the length. The length is 5 divided by 2 is 2.5. When you convert 2.5 into integer, it gives you 3. So 0, 1, 2, 3. So it's picking 16. I believe it's picking 16 as the middle. So even though this passed our requirements from like a QA perspective, a QA will pick up on this with unit tests and be like, yo, this is giving me unexpected answers. So what we can do is we can look at the forums and we can see what other people have done for this. So it looks like new list is equal to list start plus end list. New list, remove list end, return new list. So let's test this. Okay. So what I'm going to do is I'm going to look at this on the side and I'm going to put this in and I'm going to tab this. So this is the suggested coding for it. New list is equal to list from there to start, from this to end, from end on out, and then remove the list end. So we didn't talk about remove, and I don't think Codecademy talks about it, but this is a method that you can use, and this will remove the index list to end and return new list. Let's run this. Ah, that unit test passed. So the way that I initially wrote my code, let's see where I went wrong actually. So where I went wrong here is that I never needed to find the middle of the list. Okay. My new list could have equaled to lst end colon, right? And then we remove that, and if we just run this by itself, it fails. Okay. Because we need to remove, which remember, remove happens to be a method, just like it's a method that goes after something, as opposed to, so len, length, goes before you enforce it. Like, remember reinforcing, let's see, let's go back. We were enforcing integer data type here. Remove is a method that goes after it. So let's take a look. So remove, new list, remove, and then you have to put a parenthesis, and you have to put what you're removing in it. And this, we're removing the end index. So in this case, it'll be the fourth index, which would be the end. And then we'll run it. And that's a better way to do it. So let's copy all this. And again, there's no shame on going to the forums and figuring out a better way to do it, because now we know that this was the code that we needed. Let's create a file, new file, and let's save as. And we're going to call this one remove middle index.py. We're going to save it. We're going to paste it, hit Control S to save. And these are unit tests, one even, one odd. And then let's move on to the next one. More than end. Okay, let's reset this. Yep. Now you're going to look at it. Create a function named more than. Has three parameters, lst, item, and n. Function should return true if an item appears in a list more than n times. Function should return. Okay, so if the item appears in the list more than n times, so item n. Nope. So list. Let's see. Can I reset this actually? Can we cheat? Nope, can't. Okay, let's do this. Alright. So we're going to start over. And n. Alright, let's take a look. So if the function should return true if the item. So it's definitely a conditional statement if. And so if the item that's in the list item n, forgot how to do that. How to find, is it count? Is it count? I wonder. I think it's count. No. I think it's count. That's what Google's saying. Dot count. So if list dot item, so if list item, ooh, dot count n, true. else false. I really don't know. Let's take a look. Let's see what we get. Oh, we get some errors. Int object has no attribute called count. Interesting. Hmm. So, I forgot how to do this on the list. We have a list. We don't. So we have an item which is part of the list. We know that n is how many times does the item exist in the list. So let's not count item. So we can count items. So here, let's do this. So what we're going to do instead, okay, is we're going to print the list.count item. Okay, I'm going to run this. We get 4. So item in this case is 2. There's 1, 2, 3, 4. That is true. So count works like remove. Remember how it goes before, or I'm sorry, it goes after the thing. It's a method. It's part of a class. We'll talk about classes later on. But count is available to the variable properties that list has. Since list is an actual list or an array, it has the ability called count, which is a function that lives within it. So we're going to count the number of items, okay? If, let's see, if the function should return true if the item appears in the list more than n times. So if it appears more than n times, we're going to return true. Else, we're going to return false. And let's run this, and we get true, and it passes. So we should definitely make it fail, right? So to make it fail, to know that our test is good, we know that 3, this is 4 is greater than 3, return true. If list.count item, this should return 4. If 4 is greater than n, if 2, 3, return true, else return false. That seems wrong, right? So let's print lst. So let's do this. lst.count item. Let's rerun this. So here's a question. If 4 is greater than 3, which is true, it will pass. If we're going to change this to 5, we should get a false, which we do. It actually, I wrote a test inside of here, just because I was a little confused by the greater than less than symbol there. Okay, so this is a test. It should be false. Should be true. These are our tests. We're going to copy all this. Let's rerun it, make sure we didn't break anything. Let's copy this. Let's go back to our IDE, new file, save as. And we're going to save this as more than n.py. We're going to paste this. We're going to hit Control S to save. And we're going to move to the next one. Gotta speed it up. Gotta speed it up. We'll take a break here in about 20 minutes or so. More frequent item. Create a function. Looks like I already did this one. I'm going to reset it. Yeah, don't want to cheat. Alright, so create a function named more frequent item that has 3 parameters named a list, item 1, and item 2. Okay. And we'll try to make that as big as possible. Cool. Okay, return either item 1 or item 2 depending on which item appears more often in the list. So kind of like the same thing, we have to count. So let's get item 1, and item 1 is going to be equal to lst.count item 1, right? And then item 2 is going to be equal to lst.count item 2. Return either item 1 or the pairs more often. If the two pair the same, returns item. Okay, so now we have a conditional statement we have to write. So if item 1 is greater than item 2, okay, then return item 1. Else if and then finally return item 1. Okay, so this is interesting. Here, let's do the unit test for this. See what comes out. Else if invalid syntax. Is it supposed to be elif? I always forget. If it's elif, it is elif. Okay. Should have returned 3 and should have returned 5. And 5. Return either item 1 or item 2, depending on. More frequent items should have returned 3 and instead returned 5. If item 1 is greater than item 2, then return item 1. So item 1, list count. No, that's correct. So item 1 was 2, and it appeared 1, 2, 3, 4 times. List item 2, 1, 2, 3, 4 times, 5 times. So this should have been false. Item 2 was false, and then it should have hit this and said, well, if item 2 is greater than item 1, return item 2. And this is saying that it should have returned 3. Oh, you know what? It should have returned. I gotcha. I gotcha. So what happened was, by redefining these variables, we lost the values of item 1 and item 2. So we need to maintain those values of item 1. So we just have to rename these variables. So instead of item, I'm just going to say item count 1 and item count 2, and then I'm going to paste wherever item 1 was in the if statements. I'm going to return this, and then wherever item 2 was in the if and else if statements. Okay. And then we can return item 1 and return item 2, which is the initial value, which is this 2 and this 3. Not the counts. The counts will be stored into this variable. So we're not going to change the variable item 1 and item 2. Let's reprint it. So of course this passes. Let's make this. Is there any way to make this bigger? Hey. Alright. I want to get this all on one screen essentially. So, oh, okay, that works. Okay, so naturally, we should probably do more unit tests, right? So, in this case, 3 was greater than 2. So, let's return 2 is greater than 3. So, should return 3, should return 2. And then now let's make the 3's and the 2's equal. So let's count up the list. We have 1, 2, 3, 4 2's, 1, 2, 3, 4, 5 3's. Let's just get rid of a 3. Okay, and so it should return to 3. Or is it 2? Let's see. Okay, let's write this. Should return 3. So return 2, because we have more 2s. And then should return item 1, which is 2. Item 1 is 2, right? Yeah. Should return 2. So we should get 322. When we run it, we get 322. Those are our unit tests. Everything is good. Let's go ahead and copy all this. And let's go to our Visual Studio Code. Create a new file. Save as. More underscore frequent .py. And let's paste this and save it with our unit test in there. And move on to the next exercise. Next. Alright, middle item. Create a function called middle element that has a parameter name LST. No problem. Let's start that. Okay. If there are an odd number of elements in a list, the function should return the middle element. If there are an even number of elements, the function should return the average of the two middle elements. Very interesting. So maybe we can bring our length back in here. I don't know. We'll see. So we know that to find the middle element, the middle is always going to be equal to the integer of the list divided by 2. Okay? That is only true if it's odd. So, what we should do is this. Let's have it. Okay. Let's write our conditional statement. So, okay, we know how to get even statements. We say if the length of the list, okay, the integer of the length of the list. No, we don't need the integer there. We don't need this. We don't need this. So if the length of the list modulo, which gives us our remainder, is equal to 0, we know that it's even. Anything that does not have a remainder when divided by 2 is always going to be equal to 0. So if the remainder is 0 when divided by 2, it's always going to be an even number. So if it's an even number, we need to find, and I'm going to put in comments, so let's press enter, find the middle two numbers, which should be, remember our little formula, middle divided by 2 and middle divided by 2 minus 1. And I think we use the letter n here to represent any number. Remember, these are formulas, remember that? And then we erase them. Okay. So to find the middle number, we're going to take middle, divided by 2. And this will get us our first number. Number 1 is going to be equal to middle divided by 2. Number 2 is going to be equal to middle divided by 2, or num1, right, minus 1. So let's print num1 and num2. And I don't know if we can print those because they're integers, but let's try it anyways. Let's run this. Does not match. I didn't love what? I'll just hit enter here. No, that matches. Let's hit enter here. This matches. Oh, you're killing me, Codecademy. You're killing me. Let's run this, see if this works. Unindent does not match outer layer indentation. So I wonder if this is all off by like a little bit. So I'm going to try to shift tab it, and then shift tab it. Let's see. Tab, shift tab, tab. Let's run. Nope. Really? You're gonna make me do this again? Okay, so here's what we're gonna do. We're gonna save this on a notepad. We're gonna save this into our IDE, and we're gonna repair it. I think using Visual Studio. File, save as. Let's new file, save as. Let's call this middle number finder.py, and let's paste this in here. Let's fix this indentation here by hitting shift tab, hitting tab, right? And then everything under the if should be tabbed over 1. Okay. And let's go and delete all of this, and we're just going to retype it because Codecademy sometimes is a little buggy when it comes to typing this stuff. Okay, so we said so we declared middle, and we said middle is going to be equal to an integer of the list divided by 2. Okay, we're going to write a test with that prints out middle. Okay, and we're going to run it. And we put a slash there, and we're going to run it. And let's see. Int must be string bytes and not list. Interesting. Let's print out middle. str delete. Oh, you know what? Is this the thing we've come across this before, where middle is an object? So watch, let's return middle, and I'll return like this weird memory call, right? No, that's not just it. We also have to get the length. Returns 3.0, right? And if we return 3.0 integer, we get 3. Cool. So we're going to enforce the integer on the variable's length, and we're going to remove this enforcement here, and we're going to run this. We get 3. Cool. So we're able to get 3. So the index 3, 0, 1, 2, 3 is the middle. Okay? And then if you notice, if you subtract 1 and get the second index, this would also be the middle number. So the middle number we have. So what we need to do is we need to say if the middle, if the length of our list, okay, modulo 2, remember, because if it's even, it will not have a remainder. If this statement is true, okay, then num1, we're gonna say, God, we can do second middle is gonna be equal to what our middle is minus 1, right? And those are our 2 indexes. And then what we can do is we can say, okay, let's return the middle element, the list index at middle and second middle. Return middle, okay, plus second middle, okay, and these are indexes that should be numbers, and then we should divide this by 2. I don't know if this will work. We're gonna run it. Is -9 the average? I don't think so. It may be. 14 divided by 2 is -7. So let's put some parents around this, right? And let's see what happens. -7 is correct. However, they're saying that this is wrong. And the reason it's wrong is because we didn't write the the we didn't write the even. Or I'm sorry, the odd statement. The odd statement says that you should just return whatever the middle is, the middle index. So the LST middle, which is the index number. And so let's run this, see what happens. And it passes. Yeah. Woo! That was kind of confusing. So -7 is if it's even. So what we're going to say is should return -10 plus -4, okay, divided by 2 is what it should return. That's what our function should return. So it should return this, okay? And then we should make an even one. And what we're going to do is we're going to copy this. And we're going to print this. And we're going to remove one element from it. And then it should just return -10. Should return -10. Because -10 is the middle number here. Because 5 and 2, -4 and 4, boom, right in the middle. Let's run this. -10. Our unit test passed, our function passes. Let's copy all of this. Let's go back into our IDE where we had our stuff stored. Okay, and let's copy all this and print it with the unit test active. And cool, let's save it. Make sure you save it. All right, we are going to go ahead and I'm going to take a break now. And I will be back with the next video. We will finish the remainder of these, and we'll see if Kevin's online. Okay, we'll see you in a couple minutes. And I'm back. Okay, so next function, append sum list. Write a function named append sum that has one parameter named list. Let's just do that right now. Spell correctly. Okay, sum has a parameter called list, so it's going to take in a list. So if you notice all these functions take in a list. So it's important to stop here and realize that when dealing with real world situations, a majority of things that you're going to have to parse through or you're going to get back in a REST call, a lot of it comes back in a list. So that's why it's important to pay attention to these functions specifically. Okay, so the function should add the last two elements of the list together and append the result to list. It should do this in a process 3 times and then return LST. For example, LST starts as 112. The final result should be 112, 3, 5, 8. So it should append, so it adds 2 and 1, then adds 3 and 2, then adds 5 and 8, then adds 8 and 5. Huh. That's interesting. So here's our unit test. And let's go ahead and stretch the screen out a little bit so we get a little bit more room to code. Okay. So the function should add the last two elements of the list together, append the results to list. So unfortunately here we haven't dealt with loops yet, so we're not going to be able to use a loop to do this. So it needs to return. So we have to do 3 operations, right? So let's write this in our little thing. So there's going to be 3 operations where we add the last 2 list items. So the structure we know is that it's going to have to be, LST plus equals, right? The sum of whatever the last index is, right? So LST and then the last index. So the last index in Python, if I remember, it was -1. I'm going to Google this really quick. How to find the last item in a list Python. Let's see what Stack Overflows says. So list -1 should be the last item. So let's just print this out. Let's make sure we're getting our facts straight. Let's print this out. So 2 is the last item. So that's correct. So that would mean the last 2 items would be -1 and -2, right? So, well, -1, yeah, so it should be 3. Okay, so let's just print out 2 by itself. And we get 1, so we get -2, which is this 1 right here. So it grabs this 1. Okay, cool. So we have our framework, right? So for our framework, what we're going to do is we need to add, so I'm going to say sum is going to be, first I'm going to get rid of my comments. And I'm going to write I'm going to say sum, which apparently I can't use. Let's say list sum is going to be equal to whatever my list -1. Remember, brackets, not parentheses, which is my last digit, plus my second to last digit. Okay, and then list LST plus equals whatever the LST sum is. Okay. And so what we can do here is we can print out LST, and what we should see is we see 1, 1, 2, 2, 3. Let's run it. We can't. We got some errors. Type int. Where did this fail? Print append sum 1, 2 script pi line 4. Oh, because this isn't a number. This is a list sum. Well, this should be an integer, right? Oh. We gotta do that append, right? We have to do this. We can append a single item by using the append method. So let's try that. There we go. 1, 1, 2, 3. Great. So let's rerun the same command and then append it. And we have to do it 3 times. Oh, this is why we need a loop. Terrible. Let's run. Cool. So it does print out that correctly. So we're just going to return list and run it. And it passes. Okay, so normally you would just loop through this, right? And you would say, I is equal to 0. If I is less than 3, loop through. When you've looped through 1 time, increase I by 1. So I counts up to 3, and then it would do this function right here 3 times. This take the last digit and the second to last digit, add them together, and then add them to the list. And then, so this is just a huge chunk of nonsense. So here's what we're gonna do. I hate to put this into our IDE because it's like if you have a loop, you should go back and refactor this, right? But we are gonna create a new file called append sum. Save as. No, file new. File, save as. Append underscore sum.py. We're gonna save this. We're gonna paste this. Okay. We're gonna save it. Control S. And we're gonna move on to the next item here. Larger list. Write a function named larger list that has 2 parameters, list1 and list2. Done. The function should return the last element of the list that contains more elements. If both lists are the same size, then return the last element of list 1. Cool. So let's go ahead and stretch the screen here so I can get my unit test on the one line. So a couple things here. We can actually think about our test first in this case. So so here's list 1, which has 2, 3, 4. 1, 2, 3, 4. Should return the last element of the list that contains more elements. the last element of a list. So these are equal to actually. So should return last element of list 1. Return, we're going to say should return 10, and then we'll get rid of this here. And then let's get rid of this. And should return 5, right? So what we did is we changed the size of the list. We have 2 lists here. We made one list here bigger than this list here. So first list is this list, which has 4 elements. This has 3 elements. This has 4 elements. This has 3 elements. So the larger list should return the last element of the largest list. So the largest list here is this list because it has 4 elements and should return 10. So that's where we get the return 10. This is a smaller, so this list is a larger, so it should return the last number of the larger list, which is 5. And in this case, these are equal. So when they're equal, it says it should return the last element of list 1, so it should return 5. So our output we expect to see should be 5, 10, 5. So let's go ahead and uncomment these. These are, again, our unit tests. And so what we need to do is we need to compare the list 1, the length of list 1. So if length of list 1 is greater than the length of list 2, okay, then what we want to return list 1 last element. Okay? Right? Function should return the last element of the list that contains more elements. Yes. Okay, let's go to our else elif statement, which says that if the length of the list 2 is greater than the length of the list 1, okay, and you could put less, list 1 is less than, you could do that too, but I'm going to keep all greater thans on the same sort of, I'm going to keep everything greater than, so that way I can focus list 2, and we want the last element of this. Okay, and finally, if they're both equal, then just return lst1 last element. So we should expect to see 5, 10, 5. We run it, we get 5, 10, and 5. Our unit test pass. Look how quick we're doing this now, guys. And let's go ahead, and if anything, it took longer to put the unit test together than it did to write the function, right? So we're going to save this. We're going to go into Visual Studio, new file, Control-N. We're going to paste our work. And we're going to save our work. And we're going to save it as larger list.py. We're going to save it, and it turns everything into Python. Wonder if I can even run this. Looks like, yeah, it runs 5, 10, 5. So that's cool. Let's go ahead and clear our terminal here. And let's go back to the lesson. And next up, combine sort. Okay, so we already know that we need to write a function called combine sort that has a list, 2 lists as our parameters. The function should combine the 2 lists into one list and sort the results in a new sorted list. So we need to return lst1 plus lst2, and we need to sort these. Now, can we write sort? We write sort before the list, right? Can we do that? I have no idea. Let's go ahead and uncomment our unit test here. And let's just run this. Oh, sort is not defined. So we can't just, yeah. Now, list 1, list 2. Now, can we do a dot sort on them? I don't know. Let's run. So, yes. So, yes, it did sort them. but it did not print out. So it printed out the memory reference where it's stored, right? But it did not print out the list because I think we have to type in list before this and then run it. Nope. Let's save this into a variable called new list. We're going to equal to sort, and then we're going to say new list is going to be equal to a list of new list. New, let's see. And let's run this. And let's return new list. Let's run this. Okay, so obviously it's not iterable. So when it sorts these, it's making each one of these into an object. So I think what we can do is that we can say we have to call dot sort on each one of these. Well, first let's just try to concatenate both of the lists together. Let's not even do anything fancy. Let's just say list 1 plus list 2. And let's see if we get one list. We do. So we do get one list. All right. So now we have new list. And we can say new list is going to be equal to sort. Let's just say new list dot sort. And again, I really believe that the sort function. Let's run it. We can't do that like JavaScript, can we? We can't combine sort new list dot sort. New list reference assignment. So I'm going to Google sorting list in Python. See what I come up with. There is a sort. I think there is. List dot sort. So is it? No. Is it sorted? Dot sort. No, it is. So it is dot sort this. We can't store it into a variable, maybe? New list is not defined. Well, it would help if I did that correctly. Huh! Okay. So, let's see if storing it into a new variable even mattered. It did matter. We can't store it into a new variable. We have to actually do we actually have to do a method on it, which is just dot sort. Okay, and that managed to sort everything. So here are two lists, and I guess we can write one more unit test that would combine sort a list of one thing with a list of one other thing, and we'll put -1. And right, let's copy this actually. Copy. And then here we're gonna say should return paste. I don't know why the brackets are showing up in a comment. And then we know that this should return bracket -1 comma space 1, right? And let's run this. Yeah. So it does pass our unit test. Let's copy this and let us go back to our IDE. Control N for new file. Paste it. Save it. Control S. And then we're going to say it is, what kind of sort? It's a combined sort, right? Combined sort, or a combination sort .py. Combined sort .py. Let's save it, and here's our unit test down here for the function. All is well. See, we're starting to churn through these. A 10, append size. Create a function called append size that takes a parameter called list. Deal. Okay, the function should append the size of the list inclusive, meaning it includes the thing we append, to the end of the list. The function should return a new list. For example, list was 23,108. The function should return 23, 42, 108, and 3, because the size of the list was originally 3. The function should append the size of the list to the end of the list. Oh, that's easy to do, right? Because what we need to do is we need to return the length of the list, right? The length of the list is a number. So let's say we'll call this num. Num is equal to the length of the list. Okay? The length of the list is the size of our list. And then we're going to take our list and we're going to append whatever that num that came back was. And then we're going to return LST. And so let's make our screen a little bit bigger again. Here is our unit test. So this should return 23, 42, 108, and 3, which it does. Let's copy this and let's write should be that, and then let's write one more unit test. Should return 2.1.2. Right. I don't know if it should be a space and a comma or a comma. I don't know. I don't really care. All right. So it should be that. So what we can do is we can grab this and we can repaste it, and then we can get rid of all of our numbers inside here, and we know it's going to be a 2 and a 1, and then it should return 212, 212, because 2 is the size of the list, right? There's 2 elements in this list. The indexing is 0 and 1, right? The index 0 and 1 is 2 elements. Cool. So let's copy all this, go back to our Visual Studio, Control N for a new file, Control V to paste, Control S. I'm going to just name it after this, append size. Let's go back to Visual Studio, append underscore size.py. Let's save it. But bam. So we have our function with our unit test. And let us go back to finish up this. Every 3 nums. Okay. Create a function called every 3 nums. That takes a parameter called start. Function should return a list of every third number between start and 103. For example, every 3 nums 91 should return a list of 91, 94. If start is greater than if start is greater than 100, it should return an empty list. So we know our first condition is going to be if start is less than 100, right? That's our condition in order to run this. I'm just going to say return, and then I'm going to say else. It should return an empty list. Right? And here is our primary test here. Our primary unit test. And we can already write our other unit test, right? We can make this 101. And we can print it out. And start. Let's go down here. Invalid syntax, because I didn't initialize that with a function. So cool. We know the first one prints out none. We're okay with this. Okay, so now let's think about how we're going to do this. The function should return a list of every third number, starting with start. So if we start at 1, it should take the input, which is start, and it should go. Okay, so why is that wrong? Return start. Plus 3 to 100? I don't think that's right. Nope. You know what? We can say plus equals. We could say start plus equals 3 to 100? That doesn't make any sense. Plus equals 3. So this is one of those things I'm going to be looking at a hint. Oh, we used the range function. With 3 parameters, generate your list. All right, so list is going to be equal to range. Oh man. Range start, comma 100, comma by 3. Yeah. So this says where the number starts, go to 100, and then do it by 3. If start is less than 300, then return LST. Let's run this. That certainly did not work. Oh, we have to make it list? List? We have to, that's right, we have to define it as a list, a range of a list. Okay, should have returned 91, 94, 97, and 100. So that means our condition here should have been 101. It should have been actually less than or equal to 100. Right? And that way, well, that did not work. If start is less than or equal to, oh, no. 101, run. Oh, okay. And let's just make this less than. Let's see what the conditions are. Between start and 100, inclusive, so it should have been less than or equal to. And how we test if it's inclusive is we should print every 3 nums between 100, and then this should print out 100 itself. So these are the 3 test cases. This is every, and this should be a lower number. 91 should be like 3. But anyways, let's go ahead, copy our function. Let us go to Visual Studio Code, Control N for a new file, paste everything we have, Control S, and type in every third number.py. Let's save it. Well, bam. All right, and that does it for our functions in list series. Up next, we're going to be starting loops. Hopefully Kevin will be with us, so it'll be less boring. Thank you guys, and we'll see you next time.